That is what BF3 would look like in 3 dimensions. Now, just as before, as possible. So
Okay.
some molecules that have 3 things around them, okay? But these 3 things are not all bonds. Here's an example of this. SO2, okay? It's got 3 things on the central atom. It's got bond here, that's 1 thing. A double bond here, that's 2 things. But then it's got this unshared electron pair up here. These 3 things all have electrons in them, so they all want to push away from each other. So what shape is SO2 going to have in 3 dimensions? If you think it's linear, and the 3 of these atoms are all lined up in a row,
that's not right, because you're not taking this unshared electron pair into account. To figure out the shape of this, let's go back to this trigonal planar molecule, okay? In this trigonal planar molecule, we had 3 things around a central atom. It's just they were all other atoms, okay? So this is how you arrange 3 things around a central atom to be far away from each other. Now, in SO2, we're going to get a shape that's very similar, except it's that one of these atoms from the trigonal planar shape is going to have been replaced by an unshared electron.
We can't see the video.
Otherwise, look at how similar they are.
All right.
Okay, it's atom, 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 atom. It's just this atom here.
There.
Been replaced by this.
Sorry about that. Is that better?
But these atoms
Yeah, thank you.
are still in
Thank
the
you.
same place because this unshared electron pair pushes the atoms away from each other, just like this atom did. Okay? So they're based on the same shape, 3 things around a central atom. It's just one of these from the trigonal planar shape has been replaced by an unshared electron pair. Okay? So this molecule here, we call this a bent molecule because instead of being in a straight line, the atoms are arranged in this kind of bent shape. Looks like someone just grabbed it and bent it like that. So what are the angles going to look like in the bent molecule? Well, in the trigonal planar molecule over here, when you had 3 atoms, the angles between any 2 bonds were 120 degrees.
Okay, we're going to skip the angles
In the
because you don't
bent
need to know
molecule,
these.
though, around the central atom. CH4 here has 4 things around a central atom, and they are all bonds to other atoms. So each of these bonds contain a pair of shared electrons, and that means that the bonds all want to push against each other and be as far from each other as possible. This molecule, CH4, is going to have this shape in 3 dimensions. Okay? This is called a tetrahedral shape, and it's how you arrange 4 bonds as far away from each other in 3D as possible. Okay? Tetrahedral. And in the tetrahedral molecule, there are 109.5 degrees between any
And you don't need to know the bond angle.
any 2 tetrahedral shape with 109.5 degrees between each bond. Now NH3 here also has 4 things around a central atom, but not all of them are bonds to other atoms. Okay, so we have 1, 2, 3 bonds, and then a 4th thing that's a lone electron pair. So what's its shape going to look like in 3 dimensions? I'm going to go back to this tetrahedral shape for just a minute because this is how we arrange 4 things around a central atom when they're all other atoms. Okay? But in this shape, they're not all other atoms. Okay? So NH3 is going to end up having this shape, which is called a trigonal pyramidal shape. Look at how similar it is to the tetrahedral shape. Okay? I'm sort of showing them on their sides here. It's just that the atom that was up here when we had 4 atoms around the central atom has been replaced by an unshared electron pair here. Okay? So we've got 3 atoms. 3 atoms are the same between this, and it's just this atom has been replaced by an unshared electron pair. So this has a shape that we call trigonal pyramidal, and we call it trigonal pyramidal because if you look at it from its side, it kind of looks like a pyramid. Okay, got these 3 atoms pointing down. All right. Now, For angles in the, I don't know quite where to put. And then we're done with the VSEPR video. Here's the last molecule we're going to look at, water, H2O. Okay? This thing has 4 things around a central atom. 2 of them are bonds, 1, 2, and 2 of them are lone electron pairs, 1, 2. So what's its 3D shape going to look like? How can we arrange these 4 things as far away from each other as possible in 3 dimensions? As before, I'm going to look back at my tetrahedral molecule, which shows how I arrange 4 atoms or 4 bonds as far away from each other as possible in 3D. For H2O, though, only 2 of the 4 things are bonds. The other 2 are lone electron pairs. Okay? So that means that I'm going to end up with a shape like this. Okay? I've got my 2 atoms down here, hydrogen and hydrogen, but then I've got my 2 lone electron pairs up here. Look at how this is similar to the tetrahedral molecule if I look at them from the side. Okay? I've got atom, atom, and atom and atom. Okay? It's just these 2 atoms from the tetrahedral molecule have been replaced by these 2 lone electron pairs from the water molecule, these unshared electron pairs on the oxygen here. Okay, so look at that from the top, how they have very similar structures. It's just these 2 are missing, and they've been replaced by the lone electron pairs. We say that this molecule has a bent shape because these atoms here are not in a straight line, but they're bent like this. Now, what are the angles here? Let's look at the tetrahedral again, which had 109.5.
Okay, I'm going to pause this because again, we don't need to know angles, but there are a couple things I want to point out before we start working through how we use that table. So first thing is your Lewis drawing. You can't just look at that and based on the way your elements are aligned here, you can't use that alone to judge the shape, okay? Because it looks like this is a straight line. So we would say, oh, that's a linear molecule. But you can't do that. There's other things you have to consider because this is not a true judge of what the molecule looks like. You would never know that it's actually like this. Because if you pulled off any of these 2 atoms, you're going to end up with this shape, okay? So let's now go to the table that you're going to use to help you figure out the shape based on the correct Lewis drawing. Okay, so I'm going to pull up, the one I have in the PowerPoint still has numbers in the second column, but I'll refer to yes or no so you know how that relates to the other table I included in Google Classroom. Okay, so this is the table you're going to be able to use. Again, anywhere there's a 0 here, that would say no on that other table. Anywhere there's a number, that would say yes, okay? So let's talk about the different sections of the table here. First of all, let's look at the appearance, okay? So these are not Lewis dot diagrams. Okay, and what I mean by that is a Lewis dot diagram is 2-dimensional and it's all on one plane. Okay, it's flat on the paper. These drawings are shown to represent a 3-dimensional structure that is similar to the Lewis drawing, but it's not exactly the same. For example, if you go to tetrahedral, which is halfway down, we know that when we have a central atom with 4 things around it on paper, it essentially just looks like a plus sign with the central atom and then 4 things around it. Okay, this looks a little bit different. What this is showing is A just represents any central atom. Okay, so this is whatever atom you put in the middle. The 4 X's around the outside, that just shows you that 4 possibly different atoms are around the outside. The wedges, the solid wedges, like the one connecting to the X on the bottom, That is to represent what an atom would look like coming out of the board. Okay, so again, remember, we're trying to go for a 4-dimensional or 3-dimensional look here. And the dashed line wedge going back is showing you something that would go backwards. So if you remember the tetrahedral molecule he showed you, it kind of looked like a tripod with a stem on top, okay? That is what that 3-dimensional drawing is supposed to show you, but in fact, it doesn't really look like our Lewis Scott drawing. So do not base your shape from this picture alone, okay? We're going to use the first 2 columns here to help us figure out the shape. You can kind of go back and compare it then to this, but again, your drawing won't look exactly the same. So what do these mean? Our first column here is bond areas. So the key to figuring out your shape is that you need to know which atom you're looking at to reference the bond areas and the unshared pairs. It is always the central atom in your drawing. So I'm going to give you an example. Move this up here. I'm going to draw NH3 for you. I'm not going to walk through the steps right now, but we will do some more practice with that again. So if I had a molecule where I had N in the middle, okay, then it was bonded to 3 H's. Okay, so we connect these dots for bonds. N had 5 electrons to start because it's group 15, so we need 2 extra electrons up top there. So let's take a look at how we figure out bond areas and unshared pairs. So first of all, we are only looking at things connected to the central atom. These hydrogens are not directly touching the hydrogen atom, but their bonds are. So what is connected to my central atom? Well, we have this bond is touching my nitrogen. This bond is touching my nitrogen. This bond is touching my nitrogen. And we have these extra dots or extra electrons up top. So now we start in the first column, bond areas. Well, here's a bond, here's a bond, here's a bond. That means we have 3 bond areas. So now we go down and we find any 3s. Here's a 3, and here's a 3. So because there are 2 groups that have 3s, we now need to look at the next column. In the next column, we are looking to see if there are any extra dots that aren't paired up. So these dots were part of a bond, so we can't count those. But look, here we have dots that aren't connected to anything, electrons that aren't bonded. So therefore, on the other table, this says no. Okay, so are there any unshared pairs? Yes, there are. So your answer is going to be 3 bonds. Yes, we have unshared pairs, so that's going to make this trigonal pyramidal. This next column, where we talk about polarity, we'll go into that later. But again, notice my drawing here does not look exactly like this drawing because this one shows these all pushed down. This one just shows this plus sign, okay? And these unshared pairs may have gone on any side depending on where you drew your hydrogens. Okay, so we're just going to use these 2 columns to do that. Okay, does anyone have a question about what a bond area is, what an unshared electron is, and what's my last question? Oh, what the central atom is and how we look at things around the central atom. Are we good with that? And we're going to do more practice to make sure you're comfortable. All right. Let's do some more practice then. Okay, here's NH3. I actually have that one on the next slide. but we'll skip that one since I did it there. Okay. So here's two more examples, and I'm going to take a little more time to walk through the Lewis dot process. Some of you are really good at this. Others are still struggling a bit. So hopefully seeing me walk through it again will help you. All right, what is the shape of HBr? Before we can determine shape, we need a Lewis dot structure. So we have to take the time to draw it. So we have hydrogen. Whoops. We have hydrogen. Draw. We have the hydrogen atom, and then capital B lowercase r is bromine. So we have one hydrogen. We have one bromine. I'm going to take the time to draw the individual Lewis dot structures just so we can put them together. Hydrogen is in group 1 on the periodic table, 1 electron. Okay, it doesn't matter which side you draw it on. Bromine, group 17, so it has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Okay, so 3 pairs and a single. There's only 2, so we don't need to worry about a central atom. They have to go side by side. They could go top to bottom. It doesn't matter. We could do the Br first and then the H. Again, it doesn't matter. Side by side. Hydrogen has 1 electron. I know it's going to bond to the bromine, so I'm going to go ahead and move it to this side just to make our picture pretty. Bromine has 3 pairs and a single. Again, I'm going to put the single on this side just because I know it's going to bond to the single from hydrogen. And now I'm going to fill in the remaining 3 pairs. Okay, so now we need the shape. So we're going to go over here, and we remember that these 2 things are determined from the central atom. Was there a central atom here? Can you have a center when there's 2 things? No. Okay, so there is no central atom. So by default, any 2 atoms that are connected are linear. If you connect 2 dots, it has to be a line. Okay, point 1, point 2, it's a line. So anything with just 2 atoms is automatically linear. All right, this one's a little bit harder. So we have a carbon, group 14, it's got 4 electrons. We have 3 hydrogens. Again, group 1 each, so they each have 1 electron. And then we have 1 fluorine, group 17, 7 electrons. 1, 2, 3, 4, 5, 6, 7. Okay, so we have more than 1 atom here, so we need to figure out the central atom. Here's a hint. If you ever have carbon, it's the central atom. You don't need to look any further. And hydrogen can never be the central atom. So we're going to put carbon in the middle with its 4 electrons. We have 4 more things, so we're going to put 1 on each side. It doesn't matter which sides, as long as you have 1 on each side. Okay, again, we want those single electrons to pair up to form bonds. So each hydrogen has a single electron. I'm just going to move those onto the side that has the bond and connect those. So there's my hydrogens. Fluorine has 7, but again, we're going to put the single over here with the other single and form a bond. And now we have 6 electrons left. Okay, now the shape. Yep, tetrahedral. And this one is easy because there's only 1 of them that has 4 bond areas. So remember, anything touching the central carbon is going to count. So we have a bond here, a bond here, a bond here, and a bond here. So we have 4 bond areas. You don't need to go any further because there aren't any other 4s, but you could check to make sure to see if there's any unshared pairs. And in this case, there aren't any electrons around the central atom that are connected to something. So this is a no, and our shape is tetrahedral. Okay, again, the picture doesn't really look like this, but it does have those 4 bonds. Okay. Notice I'm not looking at any of these outside atoms to see what's around them. All that matters is what's touching that central atom. Okay, we already did NH3, so we're going to skip that. So now you're going to do a little practice here. If you are using a printed version of the guided notes, these and the next page are in your guided notes. So you can pull those printed versions out and work on them. If not, you're going to want to do these on paper. So there are 3 examples that I'm going to have you do. You're going to figure out CO2. Again, draw the Lewis dot structure, figure out the shape based on this information, H2O. And this is BCl, as in chlorine, 3. So there's 3 chlorines and 1